So we continue with superbubble-driven galactic winds, realistic galaxies for moderate feedback energy.
Okay, everyone can hear me fine? Great. So I'm going to be talking a little bit about the other end of how gas hangs around in galaxies, more specifically how it gets out. In particular, I want to talk a little bit about L-star galaxies. These are galaxies like the one we live in. They're the most common, most efficient star formers in the universe, and they typically have stellar mass to halo mass ratios of about 3 to 5%. Morphologically, these things tend to be disk-dominated and filled with young stellar populations. We find them in our Schechter function sort of around here at 10 to the 12 solar masses or so. Now, unfortunately for us theorists, there has been some tension between the theory of how these things form, in particularly simulations of their formation, and the observations. So if we go back and look at something like the Aquila Comparison Project, we find that galaxies simulated with a wide range of different subgrid models for both their star formation and their feedback tended to produce too many stars in the stellar mass-halo mass relation, and tended to produce very strongly peaked rotation curves indicative of massive bulges. Now, the only ones that managed to keep their star formation down tended to have very, very strong feedback that ejected large fractions of the baryons within these galaxies. So we should really start thinking now about how specifically galaxies get their gas. We know that gas is accreted and removed over the entire history of the galaxy. We know that it comes in through both the simple hot accretion and the cold flows we just heard about. And we also know that it can be ejected either permanently out to the virial radius by a galactic wind, or temporarily, which then rains back down through a galactic fountain. And this, of course, raises the big question, what is powering these outflows? I'd like to show you today how superbubbles, driven by supernova alone, are an ideal mechanism for driving these outflows. So superbubbles are a natural consequence of clustered star formation, and they result in a much more efficient transfer of feedback energy to the ISM than an equal spread of isolated supernova throughout a larger region. The key physical